What if I told you that Interstellar is one of the most scientifically accurate sci-fi movies ever made? From wormholes and black holes to time dilation and extra dimensions, this movie is packed with real physics that could change the way we think about the universe. But how much of it is fact, and how much is just Hollywood magic? Today, we're breaking down the real science behind Interstellar, explaining the mind-bending concepts you saw on screen and how they connect to actual physics. Buckle up, because this is going to be a wild ride through space and time. One of the most breathtaking moments in Interstellar is when Cooper's team travels through a wormhole near Saturn. But is this just science fiction? Or could humans actually use wormholes to travel across the universe? A wormhole is a theoretical shortcut through space-time. Imagine space as a two-dimensional sheet of paper. Normally, to get from one side to the other, you travel in a straight line. But if you fold the paper and punch a hole through it, you can instantly connect two distant points. That's essentially what a wormhole does in three-dimensional space. These are based on Einstein's general theory of relativity, and mathematically, wormholes are possible. However, there's a big problem. They wouldn't stay open long enough for anything to pass through, unless we had exotic matter with negative energy to stabilize them. And so far, we haven't found anything like that. So, could humans ever use a wormhole to travel to another galaxy? Theoretically, yes. But practically, we're far from making it a reality. Next up, we have one of the movie's biggest stars, Gargantua, the massive black hole. And believe it or not, this is the most scientifically accurate black hole ever shown in a film. Gargantua is a supermassive black hole with a glowing accretion disk. This is a swirling cloud of gas and dust that gets heated up as it spirals toward the event horizon. The reason it looks distorted is because the intense gravity bends light around it, an effect called gravitational lensing. In fact, the visual effects team didn't just create Gargantua for cinematic impact, they used real equations provided by physicist Kip Thorne, who consulted on the film. Their work was so accurate that it even led to new scientific discoveries. One of the most shocking moments in Interstellar is when the team visits Miller's planet, and for every hour they spend there, 7 years pass on Earth. This isn't just a plot device. It's based on a real physics phenomenon called time dilation. Einstein's theory of relativity tells us that time doesn't pass the same way for everyone. The stronger the gravitational pull, the slower time moves. This means that near a supermassive black hole like Gargantua, time would slow down significantly. In reality, the movie exaggerates the effect a little. For the time dilation to be that extreme, Miller's planet would have to be orbiting incredibly close to Gargantua, almost at the event horizon. At that distance, tidal forces would likely tear the planet apart. Still, the concept itself is completely real. One of the strangest and most visually stunning moments in Interstellar is when Cooper enters the Tesseract, a space where he can see and interact with time as if it were a physical dimension. But could something like this actually exist? Some theories, like string theory, suggest there may be extra dimensions beyond the ones we can perceive. The Tesseract is a visualization of a four-dimensional space, where time is no longer linear but can be navigated like a physical location. We don't yet have any experimental proof of extra dimensions, but some physicists believe they could exist at microscopic scales or in higher energy environments, like near black holes. One of the more philosophical ideas in the movie is that love is a force that transcends time and space. But is there any scientific basis for this? While love isn't a physical force like gravity, studies in quantum entanglement show that particles can be connected across vast distances instantaneously. Could consciousness or emotions be linked in a similar way? Science hasn't answered that question yet, but it's a fascinating idea. So, how much of Interstellar is real? A lot more than you might think. While the movie takes creative liberties, its foundation is based on real physics. Black holes, time dilation, and even wormholes are all grounded in serious scientific research. What do you think? Which part of Interstellar fascinated you the most? Let us know in the comments. And if you enjoyed this breakdown, be sure to like, subscribe, and hit the bell for more deep dives into space and science.